everyone. Today we're going to be learning about section 8.8, which is on biomagnification. The learning objective for today is that you can describe bioaccumulation and biomagnification, and that you can describe the effects of these. Some of the essential knowledge you're going to gain is what bioaccumulation is, what biomagnification is, some of the effects that can occur in an ecosystem from this, some of the ways that humans can be impacted, and some prime examples of types of compounds that we typically see having biomagnification. So what is bioaccumulation? This is going to be the absorption and concentration of compounds, especially fat-soluble ones like POPs, in the cells and fat tissues of organisms. Now, because fat-soluble compounds don't dissolve easily in water, they don't enter the blood easily, and they don't leave the body in urine easily. They're just going to build up in fat tissues. So bioaccumulation, we are going to see them building up to reach higher and higher and higher concentrations in the organism over time. So as it grows throughout its life, as it keeps taking these in through the foods that it's eating, you are going to be seeing more of this building up in the organism. So bioaccumulation is like the organism itself specifically. So if we have a tuna fish who is living its life and growing, over time, this tuna fish will be getting bioaccumulation of these compounds in its fat tissue. So now we have biomagnification. So bioaccumulation is going to be on like an organism level. Biomagnification is going to be on like an entire trophic pyramid food web level. So biomagnification is where we get the increasing concentration of fat-soluble compounds in each level as we move up the trophic pyramid, or as we kind of move up the food chain or the food web. Now, biomagnification is going to originally begin with the compounds, such as like POPs or PCBs or things like that. These compounds are going to be in sediment or plants in the ecosystem. So like grass or phytoplankton, which are the little planktonic organisms that do photosynthesis in our ocean or our aquatic ecosystems. Now, you are going to have the primary consumers are then going to eat those on the bottom level of the food web. So the primary consumers, like the zooplankton, the bottom feeding fish, the insects, those then eat the plants. They're going to take in those compounds into their tissue. They're going to be getting their bioaccumulation. Then you're going to have the secondary consumers are going to eat the primary consumers, and they're going to take those compounds into those tissues. Now, remember, all the way back to Unit 1, we talked about the 10% rule, where you're going to have only like 10% of this biomass being passed on. Now, because of the 10% rule, these organisms at each successive level of the trophic pyramid, they're going to need to eat more and more and more biomass to receive enough energy, which is going to lead to higher and higher levels of these compounds over their lifetimes. So let's say that we have a little piece of grass that had a tiny bit of these POPs in them. Then these small fish eats this, and they have to eat a lot of the grass. So they get some amount that is going to be increasing, which we're kind of seeing the little red parts are representing it here. Now we have a bigger fish, like a salmon maybe, is going to go and eat those smaller fish. It has to eat a lot of the smaller fish in order to live. So it's getting more and more and more of these POPs concentrating in its tissue. Then we're going to get to the large predators, such as like salmon, dolphins, whales. They're going to have the highest levels. Now, especially if we look at this diagram here with these orcas, they're going to have tons of these like POPs and other biomagnifying compounds in their tissues, because they have it's been moved up the food web at like increasing levels, and they're going to have the most amount because they're eating the most amount of biomass that is contaminated with these compounds. Now, you may or may not notice that this diagram right here is from Seattle, and this is because our local orca population, one of the reasons that they are extinct and not thriving as a species is because of this biomagnification of toxic compounds. And it is causing all sorts of like reproductive health issues. It is causing it to where like they as a species are not thriving, and there's a very good chance they're going to go extinct for many reasons. But one of the big contributing levels is these like PCBs and organic POPs that are, or the POPs that are going to be causing the bioaccumulation in their tissues. And so essentially, they're just kind of slowly getting poisoned from all of this as it's building up in them. So we're going to talk about some specific examples. There's a lot of different compounds that do biomagnification, but these are going to be kind of some three big ones that you'll want to know for apes, and you'll commonly hear referred to as scientists talk about biomagnification examples. Now, one of them that I feel like I've already talked about a few times in this unit is DDT. It was banned in most countries, but it does still persist in sediments of many bodies of water. So it's going to be reached at much higher levels than the top predators, like all these biomagnification ones do. But one of the things that was interesting about DDT and ultimately why it got banned is because our predatory birds, like eagles and ospreys, got a lot of them, and come to find out, DDT actually causes thinning of the eggshells in birds. So if you look at this diagram here, this would be a normal egg. And this would be a DDT exposed egg. In fact, these upper level predatory birds, the DDT was making their shells so thin that the birds would go and sit on their nests and it would crack the eggs. So we actually got like a drastic drop in our eagle population in the United States. And so this ended up leading to the fact of this is why DDT was banned, is because we were seeing at the highest levels such severe consequences as this biomagnification occurred throughout the food web. Now, another example is going to be mercury. Mercury is not banned in most countries. I'm sorry, that is a typo. So do not write down this top one right here. I copied and pasted and I didn't delete it. I'm sorry. Mercury is not banned. We get a lot of mercury that is being released from volcanoes and from our fossil fuel combustion. So we get mercury being released there. Now, as again, we go up the food web, we are going to get higher levels in the top predators. Specifically in aquatic organisms, we're looking at like tuna, sharks, and whales. Now, the problem with mercury is that it's a neurotoxin, so it's going to damage the central nervous system of animals that get higher levels in it. And humans actually need to be concerned about the amount of mercury that they are consuming, because if we eat a large amount of predatory fish like tuna and salmon, we can actually get levels of mercury that can be harmful, especially for pregnant women. This is why pregnant women are supposed to avoid a lot of seafoods, because if you get decent amounts of mercury that you are ingesting from seafoods, it can cause some serious neurotoxin issues with the developing fetus. And so mercury is especially going to be dangerous for women that are of child. So this again is kind of showing if we're looking at the concentration of this pollutant, specifically mercury, if we're talking about, as it builds up, the humans are going to be having higher levels. And if we're talking about a neurotoxin, you got to be really careful with that one. And our third example is going to be PCBs. This one is not a typo. This one was banned in the USA in 1979, but it is still persistent in the soil, in the water cycle, and in products that were made before they were banned, because we still got a lot of products around from the 1970s and before that. Now, the problems with PCBs, they have quite a few adverse effects, which is why they ultimately were banned in the USA. They can be carcinogens, they can cause cancer, they are endocrine disruptors, and they also can be a neurotoxin. Now, the USA has banned it, but tons of other countries still allow PCBs. And if you remember the fact that a lot of these can still be carried through the water cycle, through wind, through soils, all of that, even though the United States has banned it, people in the United States are definitely going to end up being exposed to it still, just based on the fact that our entire planet is still interconnected. So here's going to be your practice FRQ for 8.8. Scientists suspect that the compound smedesium is released from worn down bike tires, and it biomagnifies in the tissues of aquatic organisms in a nearby lake. Identify a testable hypothesis that the scientists may use for their study. So that's going to be your practice FRQ for 8.8, and those were your notes on 8.8 about biomagnification.